Hello! In this video, we will study about Ohm's law. German physicist Ohm derived a relation between electric current and potential difference, and this relationship is known as Ohm's law. According to the law, the current flowing through a conductor is directly proportional to the potential difference across its ends, provided the temperature and other physical conditions remain unchanged. Mathematically, I is directly proportional to V, or you can say V, the potential difference is directly proportional to current, and when we remove the directly sign, we get a constant R, and that is known as resistance of the conductor. And because the relation between voltage and current is directly proportional, so we get a straight line if we draw the graph between the voltage and current, where constant of proportionality R is called the electric resistance, or you can say simply resistance. Electric resistance of a conductor is the obstruction offered by the conductor to the flow of current. Thus, electric resistance, from the formula, you have ratio of potential difference across the two ends of the conductor and the amount of current flowing through the conductor. That means you can say that 1 ohm is equals to 1 volt upon 1 ampere, and the ohm symbol is denoted here. Now, at a constant temperature, the resistance of a conductor depends on directly proportional to length of the conductor, inversely proportional to area of the cross section, and on the nature of the material. So, if we combine, we get R is directly proportional to L upon A, and when we remove the directly sign, we get a constant, and that constant is the resistivity. Now, we have studied Ohm's law, and Ohm's law is obeyed by many substances under certain conditions, but it is not a fundamental law of nature. The conductors which obey Ohm's law are called ohmic conductors, and for that the voltage is directly proportional to I hold good, and therefore the voltage current graph for ohmic conductors is a straight line passing through the origin as shown. But there are many electric devices which doesn't obey Ohm's law, and such devices are called as non-ohmic devices. Examples are semiconductor diodes, transistors, etc., which we will study later on, and the graph shown here is for a voltage current characteristic of semiconductor diode, and you can see that the graph is not linear. That means the dependency of current on voltage doesn't follow Ohm's law. It is a non-linear graph, and for non-ohmic electric devices, resistance is not constant for different values of voltage and current, because the Graph is not straight line. And one main point you have to note that graph must be straight line and passing through the origin also. Current density. Current density at any point inside a conductor is the amount of charge flowing per second through a unit area held normal to the direction of the flow of charge at that point. Note that it should be normal. If it is not normal, then we have to take the angle between the current and the area vector. Mathematically, J, the symbol of the current density, is the ratio of the current upon the area, and because we have to take the angle between the area vector and the current, so we will take the cos component, and therefore it will be the dot product between the current density and the area vector. So in the vector form, I is equals to j dot a, and you know that if there is dot product between the two vectors, then the quantity obtained is scalar. So you know that the current is a scalar quantity. So the SI unit of the current density will be ampere per meter square. Because it is a vector quantity, so it must have the direction also, and the direction of current density is same as that of the direction of the conventional current.